This is going to be an example of a binomial distribution problem. 32% of adults have made a purchase online, and we're going to randomly select 10 adults and ask what's the probability that 4 out of the 10 have made a purchase online. This meets the binomial distribution requirements because people have either made a purchase online or they haven't, and so the purchase online is a success, and not having made a purchase online would be considered the failure. These purchases are independent of each other, and the probability that we're going to use is going to stay at 32%, and we have a known number of trials that we're going to use, the 10. And so in this particular problem, the probability of a success, which we're using a lowercase p for, is going to be 0.32. And then the number of trials, when we randomly select the 10 people, as we select them, they'll either have made a purchase online or not. And then the number of successes in the question that's being asked is 4. So we could work this with the binomial formula that's in the book, but I'm going to show you how to use your calculator to do this. And so we're going to be using this distribution key above here. It's a second function key. So touch second and then vars. And then you'll have to take your down arrow and come down a little ways. And we're looking for this binomial PDF. There's another one right below it that we'll get to in a minute, but we don't want to use the CDF one yet. So get on the binomial PDF and then enter. Some calculators will look like this right now. And if your screen looks like that, you're going to enter the 10, the number of trials first. Then you're going to use your comma key, and your comma key on your calculator's right here. Then you're going to put in the 0.32, then the comma key again, then the 4, and then you can just touch your enter button in the lower right hand corner. For those of you who have a screen that looks like this, you want to type the 10 here, the 0.32 here, and the 4 here. So you have to use your down arrow key to get to each one of those and just type them in. And then come down on the paste and enter. And then all of us, your screen will look like the same as the people who typed theirs, and then you'll have to enter one more time. So all of us will get the same answer. We'll get 0.2177. So about 22% chance that when you randomly pick 10 adults, 4 of them will have made a purchase online. Now we're going to switch the question up a little bit. We're going to ask what's the probability that at most 4 of the people have made a purchase online. So now at this point, the probability of success purchasing online is still 0.32. We still have picked 10 people, but at most 4 means 4 or less. It means either 0 people or 1 or 2 or 3 or 4. We would like to answer that question. Now, you could do this with the PDF, and you've already done the 4, so you've already actually done this part of the answer. And you could do separately, you could put a 0 in there, and then a 1 in there, and a 2, and a 3, and add those results together. But the calculator has a function on it that will actually do all of this in one big swoop, so that you don't have to do the PDF thing 5 different times to get these answers. And that's what the CDF is for. So I'm going to click second here, bars that has the distribution above it. I'm coming down. And now I'm going to the CDF instead of the PDF. So binomial CDF, I'm going to enter. Again, some of you, your calculator may at this stage look like this. And if so, you're going to type in 10, then you'll use your comma key, then 0.32, use your comma key, and then you want it to start with the 4 and do 3, 2, 1, 0. So you're going to put a 4 right there. The CDF will do all of that for you. For those of you who have a calculator that looks like this, you have to type in your number of trials and come down and type in the probability of a success, and then you will type in the 4 right there, and then paste. It'll look the same as those of you who had this on your screen, and then enter. And those of you who had this, you'd have to go ahead and enter on this one. So we should now have the same answer as each other. About 81% chance that at most 4 of them will have made a purchase online. So the binomial CDF is a accumulating function. It does each one of these individually. It does the 4, then the 3, then the 2, then the 1, then the 0, and accumulates them. So changing the question just a little bit again, it says what's the probability now of more than 4 having made a purchase online? So the probability of purchasing online is staying the same. We're still choosing 10 trials, but now more than 4 would look like that. And more than 4 would be 5, 6, 7, 8, 9, 10. More than 4 would go that direction. The binomial CDF at this time does not accumulate that direction. It only accumulates like the previous problem that we did, where from a number on down, it puts these in separately and adds them together. So it will not go forward this direction, but we can kind of outwit the calculator by realizing that 5, 6, 7, 8, 9, 10, the answer to that question would be the complement of the answer to this question. So if I do 1 minus and then do the binomial CDF with a 4 on it, then I would have the answer to what I need. So I'm really doing 1 minus and then binomial CDF like that. Those of you who have the older calculator, you would type it just like that. You'd go 1 minus and then type it in, go second and find the CDF, the binomial CDF, and type this in. For me, I can do it the same way, except mine will look a little differently. I'll go 1 minus, then I go second distribution. I have to come down and find the binomial CDF. Then I'd have to type these in, come down to paste. It'll do 1 minus that, then I just enter, and then there's my answer. So you can use the CDF to get answers for things that need to accumulate the other way, but you have to be careful about what number you put back here. Because if it had said 4 or more, if the 4 had been included, like if this problem had been four or more, and I wanted the 4 probability with the answer like that, then on my 1 minus binomial CDF, I would have had to put a 3 back here, because that would be the beginning of the complement, the 3, the 2, the 1, the 0. And I want the complement of that, so that's why I'm doing 1 minus. You just have to try it a little bit and experiment with it and make sure that you can get it to work for you.